Hi, LCC 150D, Statistics for Informed Decision Making. This week we're looking at Chapter 8, and Chapter 8 deals with sampling and how we get our numbers. For the first part of the course, you've been looking at how you display data. Now we're going to look at how you get data. So we're going to see if it's important, if it's relevant, and you're going to make that decision. So you're going to have to decide whether the data that you get or you read is actually relevant, and you can make inferences. That means make decisions about them. So we're going to look at producing data and sampling. When you read an article or you see something online that says 40% of the people do this or 30% of women believe this and so on, what does that actually mean? Well, that's usually a sample, but I'm going to talk first about the population. Population up here means the whole group, everybody. The United States population, all 330 million of us, that is measured every 10 years by the census. And the census will measure the population. That means they count everybody. They count everybody's salary. They count everybody's racial background. And then they come out with these numbers. And those numbers I call parameters because that represents the population. Now, it's very difficult for us, regular people, to do a measurement of the population. If you wanted to do the whole population, you'd have to talk to every single person. So what researchers do is they do a sample, which is a subset. You see this word subset of the population. It's called a sample. And the numbers that come out of a sample are statistics. So it's pretty easy to measure. Population numbers come out, parameters. Statistics come out of sample, SSPP. So the sample is what we look for. But if you're going to do a sample, you got to be very careful. Let's say that you wanted to do a measurement of the population of the entire University of Southern Maine. Now you have to talk to every single person. That would be the population, every single person. If you wanted to know the average GPA or the average age and so on. But what you can do is take a sample, but you have to make sure that the sample represents the population. If you just talk to people in your class, that may not represent everybody in terms of the age. It may not represent everybody in terms of their racial background. So it's very important that you find a way to collect these numbers. And if this is something you plan on doing for your research paper, it's something you're going to have to really take care of. So the statistical techniques to make conclusions about the population based on the sample, that's what's going to be your decision on whether it's good or not. Here's some bad sampling designs. Voluntary response. Let's say you go to the mall and you allow individuals to choose to be in the sample, or you ask your friends or your people in the class, do you want to be in this sample? That doesn't work. Convenience sampling. Let's go back to the mall. You select that are easiest to reach. Well, does the whole population go to the mall? Not really. You might have a sample that's skewed at a certain age bracket. If you want to get a lot of men, maybe they don't go to the mall, except if you maybe do your research on Christmas Eve. Then you may have a large number of men that doesn't even represent the regular sample of your population. They're biased, so they wouldn't be very good. Voluntary responses. Here's a book. It was very infamous, Sherry Height, and she wrote a book on women in love, and she asked 100,000 women. She sent questionnaires to 100,000 women. 4.5% responded, not very high. So she used these responses in her book. So the problem was, as they've noted in the textbook, respondents, those who answered were fed up with men and eager to fight them. And the anger became the theme of the book, but angry women are more likely to respond. If you've ever looked at articles in the newspaper that are online and people will give their comments, a lot of times it's skewed towards the negative. If you read reviews about books, like on Amazon, it may be those that really like it are the only ones that answer. Those are not scientific studies. Convenience sampling, this would be as if you just called people that are at home. And here's an example here is that you just have a mice in a large cage and you take 10 of them. Well, that doesn't represent the whole population. Here's the key. This is the big one. Simple random sampling. Each individual in the population has the same chance of being chosen for the sample. So if your population is the USM student body, that means that you have to come up with every student has a number. And what you could do is take a size n. Here's the size n right here. And that size n, the larger it is, the closer it is to the population, the better your numbers will come out. The better your stats actually represent the population. So everybody has a chance. So what you do is you find these people that are going to respond to your survey by drawing names out of a hat or a table of random digits. In the back of your book, the table of random digits looks like this. It's table B. And what you do is you take a line. This is at random. You can take a line 110. Let's say that you have a population of all students, and that's 4-digit numbers. So 1, 2, 3, 4. So you can say, okay, the first person I'm going to talk to is number 3,844. The second person I'm going to talk to is 4,878. The next person I'm going to talk to is 1,833, and so on. If you have just 2-digit numbers, maybe from 1 to 99, actually from 10 to 99, then you could just go, let's say, take this line, 73, and you can also take the next thing, 19. You could take 03 if you wanted to, or just start with the next one, 32, 53, and so on. So those are different types of ways to get some random digits, and that's how everyone has a chance to be in there. And that's what I just explained. Entries are independent of each other. You don't pick one at the expense of the other. So I just told you about taking pairs. Triples is the same way. So that's called a simple random sample. Okay, so each individual gets a label, and then you use the table B. There are other ways to get this as well. So about these sample surveys, you have to make sure they're under coverage. Again, some groups have in the population are left out, maybe because they're not well, maybe you're just going into one area. Again, if you were going to just sample in the mall, you may not get older people. You may not get men. You may get just younger people. And it also depends what stores are at the mall. If it's geared for younger people, you're not going to get a whole population. The non-response, these are the people that don't answer. If you've probably been contacted, if people probably called you on the phone, you probably hung up, especially when it's during dinner time. Response bias, you have to watch out that the response bias, the behavior of the respondent, maybe they will be very angry, or the wording of the questions can be also a problem. We'll look at that in a second. So the non-response, we talked about that, and these are the ones that answered were the angry women who answered. Response bias, a door-to-door survey was conducted to determine drug use, and it would be very difficult if you knocked on the doors around a neighborhood and said, do you use meth? Well, I don't know if everyone would answer correctly or tell the truth. Sex surveys are very difficult too because people don't always tell the truth about sex surveys. If you're interested about sex surveys, I'd suggest you look up the Kinsey, Kinsey report, very famous in the 20th century, around the 1940s, around after the war, World War II. And that was very controversial because of the results that they came up. And then for this survey on drug use, is a bias from the interviewer. Would it be matter if a police officer is conducting the interview? Or is it just someone who does meth that asks around? Asking the uninformed. Here was a question. This was just a poll done in Cincinnati, and it wasn't even a real Public Affairs Act, and 1/3 of the people had an opinion about it. The way you ask questions can be also as well. Like, when did you stop beating up your wife? Is a very famous one. You can say I didn't, or I don't, or I haven't, I've never, and so that could be a biased answer. Look at reporters, especially sports reporters, when they ask questions. There's a lot of bias to it. And deliberate bias. If you find a wallet with $20, would you return the money? Or if you find a wallet with $20 in it, would you do the right thing and return the money? You can see that's a biased question right there. So an unintentional bias, I've taught several students over the past few years. How many students do you think I've taught? How many years am I referring to? Over the past few days, how many servings of fruit have you eaten? Well, how many days are you considering? What constitutes a serving? So you have to look at this. And an unnecessary complexity. Do you sometimes find that you have arguments with your family members and coworkers? So now you have two. Is it, yes, is it family workers or is it coworkers? So watch out for the wording. How often do you normally go out on a date? About how many times a month? So that's the ordering of the questions. How happy are you with life in general? So you can see there's some wording issues as well. Now I want to take a look at one of the questions I asked you to look at, which was number 28 in your book. Sampling telephone area codes. There are approximately 341 active telephone codes covering Canada, United States, some Caribbean areas. More are created regularly, especially now with population shifts as well as cell phones, and a lot of numbers are being used. So they say label the code 001 to 341 and go into the book, table B, and pick out 25 of these. But here's an easier way. You have an applet in your website where you go for the quizzes. This is kind of cool. Remember, 341, we want a standard random sampling at 25. So this is how this works. We are going to have a population of 341. So I'm putting in 341 there. And 341, see, these are all the 341s. This goes 1 to 341. Okay? Out of these 341 zip codes, area codes, or people, could be people too, I want to pick 25 at random. So this will generate a random sample. So you can see these are the numbers. They look like lotto numbers here. These are the 25. So these are the 25. So this represented, say, people. These are the 25 people I would talk to. And that would be a simple random sampling of 25 out of the population of 341. Now, of course, if I did more and I wanted a population of, say, 100, now I'm going to have even better numbers because I have closer, in fact, almost a little under 1/3 of the population. So when I do my results, they will really give me a good statistical data set, which I can make some good decisions. So basically, that's it for this chapter. Take a look at the problems that I recommended. Try the sample random sampling, or if you want to take your time, go into the book. You could have done the same thing for this problem and start with a certain line and pick 3 numbers. For instance, this goes from 1 to 341. If I did line 119, that wouldn't count because there's no 958. So how about the next one? 071. That looks pretty good. Okay. So you can keep going. You can also go down. You don't have to keep going up. You can go 354. That's a little bit high. Next one that goes on, 138. So there's your number 1 sample. Go down to the next one, 156 and 50. Or you can just go across. This is up to you, and there's no reason why you can't understand that it's beneficial in terms of simple random sampling.